In this lesson and the next few lessons, we're going to look at the alcohols, and the alcohols, just like the alkanes and the alkenes, form what is called a homologous series. Now let's just remind ourselves of what that means. Firstly, it means that all of the members in that series, in that family, have similar chemical properties, and they have similar chemical properties because they all have the same functional group. Now, the functional group in the alcohol family is the OH group, which could be written like this or like this. And so we'll look at this in a minute when we look at the various members of the homologous series. The second important thing in a homologous series is that the members have similar physical properties. That's to say, there are small changes in physical properties as you move from one member of the group to the next. For example, in terms of the boiling point or the melting point of each alcohol. And the fourth important point is that in a homologous series, all members of the family can be represented by a general formula. And we'll have a look at the general formula in a minute. Okay, so here we have the first four members of the homologous series. First of all, we've got to add the functional group, so we'll do that. We have the OH group there, and so in this case this is called methanol, then ethanol, a very important alcohol, then propanol, then butanol, and as with the structural formula we can write the chemical formula, which will be written as CH3 and then OH. So we always keep the OH group there intact, and then C2H5 OH, then C3H7, then C4H9 OH. So now you may be able to recognize the general formula. We have Cn, and then for every N carbon atoms, well, just take ethanol here for example, just look at the black hydrogens. First of all, you've got C2 and then 5 hydrogens, so we'll write that as Cn and then H2N plus 1, right? And then we'll add the OH group on at the end. Okay, so that will be the structural formula for the homologous series of the alcohols. Now, as also with the alkanes and the alkenes, you can also have isomerism with this family as well. So for example, if we were to change the OH group here and place it here, okay, we've still got the same chemical formula, but we've got a different structural formula, and that will have slightly different properties to the previous arrangement. In this case, this would be called propan and then 2-ol, because the OH group is on the second carbon atom. So for example, this compound has two isomers, propanol or propan 2-ol. Now let's just quickly consider the uses of the alcohols. Well, one of the primary uses is as a fuel. So just like the alkanes, alcohols can be burnt in oxygen to release energy, highly exothermic reactions. So we can write a general formula, okay, alcohol, that's any alcohol plus oxygen, will give us, as with the alkanes and as with the alkenes and as with just about any hydrocarbon, we're going to get two products which are carbon dioxide and water. Okay, so let's just take a specific example such as ethanol. So we'll write C2H5OH plus O2 gives us CO2 plus H2O. So all we've got to do now is balance the equation. So we'll sort out the carbons first. We've got two there, one here, so we'll put a 2 here. Then we'll look at the hydrogens. I'm leaving the oxygens to last deliberately because oxygen is on its own here. So we've got 6 hydrogens. We've got 2 here, so we need a 3. Now count the oxygens. We've got 4 there, 3 there, that's 7. So we need 3.5 oxygen molecules. You know very well that you can't have half a oxygen molecule, so we've got to get rid of that half. We do that by multiplying everything by 2. So that becomes 2, that becomes 7, this becomes 4, and the 3 becomes a 6. So there's our balanced equation for the reaction of ethanol with oxygen. Now if you're asked for another use for ethanol or alcohols in an exam question, one of those is for the fuels, and another use of alcohols is in the production of alkenes. Let's say the dehydration of the alcohol to produce an alkene. And as you know, alkenes are then very useful in the manufacture of polymers and plastics. For example, dehydration of ethanol to produce ethene. Now we'll look at this particular reaction in a later lesson.